Hey guys, welcome to the channel. My name is Srihari. You can call me Sri in short. Well, today we'll be talking something about binary codes. It will just be an introduction to the concept so that you can have a bit of an idea while you yourself start learning about these codes. Well, binary codes are just a set of ones and zeros in which your information can be encrypted. It is a more convenient method. There are, of course, other systems also, like the ternary codes, quantum computing, the alphanumeric code, hexadecimal code. But the reason why the binary codes have gained popularity over the other systems is it involves only two variables, one or zero. If you look at the hexadecimal system, it has over 16 variables, that is A, B, C, D, E, F, and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you look at the decimal system, it will have over 10 variables. Those are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. As the number of variables increases, it consumes more and more power for the software to generate and maintain such codes. Hence, binary codes are a more convenient and efficient way to store and transfer data. We all live in a world which is interconnected from one place to the other, from one person to the other, thanks to the help of internet. We are able to transmit data with the help of binary codes. Even the video which you are watching right now, even the audio which you are hearing, it itself is a form of binary code is being decrypted by your phone software. If you look at a computer software, it's made up of a large number of transistors which are constantly switching between high and low states, say 0 to 5 volts. Now, the voltage may sometimes oscillate, say 3 to 3, 4, 2 volts, in the any range between 0 to 5 volts. But the computer processor is designed in such a way that any value closer to 5 volts is read as high, any value closer to 0 is read as low. And according to the positive logic, that's the convention, we take the high state as a reading of 1 and a low state as a reading of 0. Now, let's see how the information which you upload to a digital system actually gets converted into a binary code. Let's start with numbers. If I were to represent a number, say 84, 84 is actually a decimal number because it is in numbers, of course, and the decimal system has variable of 10. So I represent the 10 variables by writing a base number as 10. Now, to represent 84 as a binary number, we actually go on dividing it by 2 and also noting down the remainders which remain. I divide it by 2, I'll get 42. Here there are no remainders, so I'll write it as 0. Again I'll divide 21. Again no remainders. Now we get an odd number. In this case, what I have to do is take the nearest number to 21, which is divisible by 2 and is also less than 21. Here we have 20. So I write as 2 times 20. Here I have a remainder of 1. I'll note it down 1. Again I divide it by 2. I get 5. Remainder 0. Again an odd number. So we should note down a number which is divisible by 2 and also less than 5. 2 2s are 4. Here we have a remainder of 1. Again I will divide it by 2 and get 1. 2 ones are 2 and a remainder of 0. Now what we do is we have to start numbering 84 to the base 10 as the number 1 0 1 0 1 0 0. And since this is in the binary code, it has two variables, so I'll represent the variables as base of 2. The number I have assigned to 84 is actually done by starting from the lowermost point, the lowermost value which remains, all the way up to the top. This lowest number which remains, the one which always remains at the end, is called the most significant bit. This is called the most significant bit, while the topmost number, the 0, is called the least significant bit. The least significant bit always comes at the right side, and the most significant bit always comes at the left hand side. That's it is. So you get the number 1010100 as a representation in the binary form for 84. To get back 84 from this number, you have to write 1101010 as a multiple of 2 raised to the place value. Place values starting from the least significant bit is given as a 0, 1, 2, 3, and goes on. Suppose I have a number say 100. I could represent this least significant bit 0 having a place value of 0. This the second number which actually comes in the tens place has a value of 1. This one which comes in the hundreds place has a value of 2. So let's return to this number 1010100. Now if I write 1010100 as starting from the least significant bit as 0 into 2 to the power 0. Remember, we must raise 2 to the place value and multiply it with the number given also. So 0 into 2 to the power 0 plus 0 into 2 to the power, and add also 0. The reason 0 I have taken is the second number, 0 into 2 to the power place value, which is 1. Again I take the next number, which is 1. 1 into 2 to the power place value is 2 plus 0 into 2 to the power of a place value, which is 3, then plus 1 into 2 raised to the power 4 plus 0 into 2 raised to the power 5 plus 1 into 2 raised to the power 6. Now if you add all these, you'll again get the number 84. Wait, no, 10 again. This is how you get your decimal to binary conversion. In the case of alphabets, each alphabet is assigned a set of binary digits having 8 bits according to a set of rules called CTF8. And it's interesting to note that a binary code by itself has no meaning. By that I mean you can't just take a random set of ones and zeros and ask what it means, what it can be really interpreted as. A binary code can be interpreted as an audio signal, an visual, a document. It could mean anything. And so it actually becomes necessary to mention the context in which you are being asked the question regarding binary codes. For instance, as per the UTF-8 coding systems, I can assign the letter J a binary code of 01001010. But the same binary code could also represent the number 84, which I had shown you earlier. If you ignore the 0, of course, because 0 itself holds no value. Well, now we have learned how to actually encode an alphabet and a number into a binary code. Let's look at how to encode a audio signal and a visual signal into a binary code. Let's start with visuals. You are able to receive visual information thanks to the thousands of pixels present on the screen, which are lighting up at varying intensities and are able to produce different amounts of light. If you look at a particular pixel, each pixel is controlled due to a binary sequence, and each of the sequence corresponds to the three primary colors, red, blue and green. Each of these three binary sequences represent a particular value of a number, which in turn controls the intensity of the light emitted by the pixel. This amount of information is sent to a video controller program in your phone software, and it controls the thousands of pixels according to the instructions given to it by the binary codes. Now let's look at audio encoding. To convert a sound wave into an electrical signal, or more precisely a digital signal, we take snapshots of the sound wave every few milliseconds, and this waveform which is observed during this time interval is encoded into a binary code. Now, this binary strand may sometimes contain a large number of characters, varying between 14,000 characters to 20,000 characters. And when this amount of information is received by your phone's audio program, it actually controls how fast the coils of the speaker should move to and fro so as to generate the required sound, and you are able to hear my voice and not any form of disturbance. I hope you got pretty much of an idea of how a binary code works, how we actually encode data into it, all different sorts of data. And now, of course, we have newer methods like uh, ternary coding and quantum computing as well. Ternary coding uses three states, 0, 1, and 2 included, while quantum computing uses two states like the binary code. The only difference is that the quantum computer can use the two states simultaneously. But the problem with these newer systems is none of them are able to provide much required physical stability for the data stored in them. Hence, the current best option for storing and transmission of data are binary codes. So I hope you like the video. Please let me know in the comments on what topics I must make videos on, and what I can improve on my upcoming videos. Do subscribe the channel. That will mean a lot of help for me. Till then, I'll see you off.